I'm too hungry. What should I do? Let's imagine.
Our aim is to build network model and calculate critical path. We plan to compare two variants of having a meal, cook it at home or go to cafeteria.
The first step is to go to the shop and buy ingredients for our spaghetti bolognese. This action will require 10 minutes.
Shopping! This way!
Our second step is to collect and boil water in cooking pot. This action will require 7 minutes. Simultaneously with the second action, we can do the third aim. It is to add oil to griddle, warm it up and wait 4 minutes. Also, we can do simultaneously with the second and third step the fourth action. It is to rub cheese on a grater. This work will require 4 minutes. To sum it up, we can do the second, the third and the fourth section in one time by different people.
Pasta, I love pasta, it's a wonderful food. Rigatoni, masticcioli, and spaghetti.
The fifth step is to add forcemeat to grill and mix it up. This action will take 1 minute. The next step is to add bolognese sauce and water. It also will require 1 minute. The seventh action is to wait and see after full concoction of forcemeat. It will take 20 minutes. The next step is to boil spaghetti. We can do this action simultaneously with the forcemeat's preparation. It will take 8 minutes.
The time reserve of an event is the period of time for which the completion of this event can be delayed without violating the deadlines for the completion of the project as a whole. Here is an example when the process rub cheese can be easily delayed because we have reserved time.
Pasta, I love pasta, take a look and you'll see. Fettuccine, vermicelli, ravioli for me.
Here we get reserved time of an event boil spaghetti.
So I can twirl my spaghetti. Grazie.
I like it with red sauce Alfredo. I like it with garlic and oil.
The ninth action is to unload spaghetti and add forcemeat with bolognese sauce in it. It will take 3 minutes.
With sun-dried tomatoes, lovely pasta, run to a boil. Pasta, I love pasta, it's a wonderful.
The next step is to add cheese and spaghetti bolognese. It will take 3 minutes, too. And the last action is to serve spaghetti with forcemeat and sauce in plates and set the table. It will require 5 minutes. That's all. Our project is done and we are full up. On this slide you can see our critical path. It's highlighted by red color and it includes 7 actions. The full work time is 44 minutes.
The critical path is the activities which have to be completed on time, and if they are not, the whole project will be expired.
Oh no, that's too difficult. I'll eat in cafeteria.
I'm right here to stay when I'm home to pray. I'll be right in my time. Living in the sunlight, loving in the moonlight, having a wonderful
Brains are mysterious, but don't worry, here's a map.
Thanks to Excel program, we managed to optimize the total number of workers. But firstly, I want to remind you the meaning of optimization. Optimization is a process of making something as good or effective as possible. In our particular case, we tried to optimize the number of workers required for preparation of spaghetti bolognese. At the same time, we tried to do that as fast as we can. So, in the first table, you can see each activity with its duration: early start, early finish, late start, late finish, reserves, and labor. Now I want to recall the definition of reserves. The free time reserve means the amount of time available for postponing or extending the beginning of work. In our situation, as you can see, we have 4 activities that we should check on the probability of optimization. They are highlighted by the red color. In the next column, you can see the number of labor required for each work. These numbers were taken from our estimation during the project. The next step was to create a line graph that represents total engagement of labor during our full work time. Below that graph, you can see our adjustments per each particular change. Each adjustment is red colored. Below our graph, we place tables with explanations why we changed the order, and adjustments are also red colored. After that, we move to the right, and there is a line chart that demonstrates labor per minute after optimization. And also you can examine small table near the line graph. It is very unstable and it shows internal scatter after each of our changes. So you can see that before optimization our variance was 0.93, and after all adjustments our variance became 0.308. It means that our numbers or labor per minute became more homogeneous and we fully optimized our work.